Okay, so without further ado, we're going to have Jon talk about Red Hat on ARM and what Red Hat's been doing there. Linaro on ARM.
Fedora.
Fedora.
Fedora?
What am I?
Okay.
Okay, thanks so much.
So, I am with the Fedora project, Fedora Linux. Can anybody in here say what the largest, most popular Linux distribution is?
Fedora?
It's not Fedora. It's Ubuntu.
Oh, well, yeah, I was going to say that.
But what's that based on?
Ubuntu?
Debian.
It's Debian.
Yeah, Debian.
So
Debian.
isn't really kind of Debian-esque?
So, I don't know. I've never used
That's
Debian
an
or
evolutionary thing.
Debian-based distro. But I always have used Fedora or Red Hat, what it used to be back in the days, and so I'm pretty hip and knowledgeable about it. So that's what I'm here to talk about today. Traditionally, I myself have always been a system administrator type person in the enterprise industry. So I've recently began getting into, participating in open source and becoming more of a contributor. I now do it professionally, actually, so that's kind of cool. I guess a few years ago, I started getting into integrating Fedora Linux onto some of these ARM development boards that we all know so well. The Panda board has always been my favorite. So that's another one of these circuit or
Yes,
Yeah, it is from manufacturer.
and Jayneil was on the Panda board team. Yeah,
Oh, cool. Okay.
You a TI guy?
All right.
he was.
It used to be.
Used to be.
So, anyway, without further ado, I'm not a very good presenter, so bear with me. I'm a Fedora community member. I help out with all the secondary architectures. Secondary architecture in Fedora is, let me just go on to the next, okay. I thought it was on the next slide. That's like PPC, MIPS, used to be ARM, and I'll go into that later. Here's our agenda. This is going to be a pretty quick talk, by the way. I used to have a demo set up for this, 2 demos actually. Didn't really work. So we're going to go into how Fedora ARM recently got promoted to what we call a primary architecture. All right, this is actually pretty cool and significant for all of Linux, really. Going to the multi-platform kernel. I'm sure some of you have heard about that. We'll talk about AR64, virtualization, our uber-duper build system, which I'm really proud of, 3D graphics, and Fedora. Talk about that. Primary architectures are first-class citizens. And when you're on a Linux distro, you're usually running on your laptop. It's probably running x86 or a 64, AMD chip. Or now you can get a Samsung Chromebook, even. So, this is ARM v7. Secondary architectures, now there's 64-bit ARM, which is pretty much all I work on all day long. PowerPC from IBM, also S390, and MIPS.
They're still making the PowerPC and the MIPS stuff?
I think MIPS was sold to a company called Imagination or something. These are the people that make that graphics chip.
Silicon Graphics.
Well, it was Silicon Graphics.
Yeah.
Who's the company that makes the
Yeah, they were the big
Power
player.
VR?
They were the big player.
Imagination Technologies,
Imagination
yeah.
bought the IP
Yeah.
for that, so I think they
When
have
was
some-
that? Like recently, or like, are we talking 20 years ago?
I think about 1 year back or something, I
Like
saw
maybe
you
a
use.
year ago?
from SGI,
Oh,
I
that long?
guess. So anyway, yeah.
I thought it was dead in like 95 or so.
Oh no, it's
That's amazing. I mean, it's a good thing.
We're still churning away on it, actually, trying to get MIPS to work. You can buy boards that have it, like router boards and
It's a
stuff.
risk. What's to know?
So, these are second-class architectures right now. PowerPC used to be kind of a first-class one, and it kind of, got demoted. AR64, I hope we're going to get promoted someday. We're starting to see hardware emerge on that, and we'll talk about that a little bit later. So the multi-platform kernel is the latest and greatest thing coming in. I guess Arndt and Olaf and all these kind of higher ups in the Linux ARM branch of things decided that they wanted to follow Spark, or what they were doing, these device tree files and stuff. And so that's what we all did. The whole industry went that way, and it was great. Not everybody thinks so, but a single kernel that supports all the SOCs and platforms, the way you can do that is you enumerate the hardware with a DTB, a device tree blob. And this replaces your board file, that some of you guys may know about. Board files are pretty cool because you can get it working. Multi-platform kernel is pretty cool because then you just have to work on your DTB and put that upstream. There you go. So support for new boards are always coming. It's more DTBs. Right now we're actually kind of going through a big thrash on the upstream kernel because we're transitioning away from board files and going to, all your device drivers have to convert. And like Android isn't really playing nice with that. They're still stuck back down on like 3.0 kernel, maybe 3.4 if we're really lucky. So right now, if you're looking to play with multi-platform kernels, if you have a lot of different devices, Fedora is a great distribution for that. I would dare say the best in that regard, because we're really big sticklers for the whole upstreaming kernel only thing.
Because the bifurcation of the development environment versus the target environment, what makes Fedora better?
Well, without getting into too much politics about it, we only use the Linus Torvalds kernel tree. And there's kind of a limited number of stuff that's working there right now because everybody's being forced to convert to this new device tree way of things. They won't accept your patches unless they're DTB, DTBIs right now. So that's pretty challenging because there's all this hardware out there. People just aren't interested to go back and upgrade. I guess, people like yourselves, were paid to work on that stuff and then the money dried out, the contract was over. We moved on to the next project. We maybe retired for 6 months or whatever and then moved on, right? So a lot of that's going on. There's a lot of stuff abandoned out there, and that's cool because we're just marching on, right? So, AR64, everybody's racing to get AR64 support. I guess the people that are best at doing this right now is actually this organization, Linaro. Is anybody here a member of Linaro, by any chance? Okay. Heard of Linaro?
Yes.
Okay, good. Well, there is a software emulator, I guess, called the Foundation from ARM. It's what I think just about everybody's been using to do the initial bring up. I think it's guaranteed to, be accurate or whatever. I think there's some hardware you can get from ARM in the form of an FPGA kind of thing, like I think they call them express boards or something. Anyway, we've been bringing it up on this emulation. It's so super slow. It's like a 200 megahertz equivalent. And so when you're compiling big, gigantic software projects we have these days, like KDE or Qt or some sort of thing like that, it could take 5 weeks just to get to a point where you have a failure and then you have to start over. So we finally unveiled some hardware. Actually, this guy John Masters did this at the Red Hat Summit. He signed an NDA, and even I didn't know about this. and was porting Fedora over to it and getting things going. So this stuff is finally starting to come out a little bit. I think the different communities may be entering into these NDAs and stuff. So I'm not really sure how much about that I can talk to you guys about. So I just won't. But I will show you a cool picture. This is the picture of the AR64 dev board that you can actually buy. You can go to a company called Applied Micro, and it's called the XKey, and you can get this thing if you have a lot of money.
So is this pre-release? Is that the reason for the NDA, or is that permanent?
Who's their, they,
I don't really involve myself with all the drama.
well, do
but-
they have partners that they're doing business with, that they're serving? Is that what, I mean, is this
Yeah.
open stuff, or is this is somebody, talk about what Arch64 is.
Okay, 64-bit ARM. It's this, earlier I said that ARM v7 is this primary architecture that we just promoted. Well, ARM came out with the next big thing, and it's 64 bits, right? So
Jesus.
we've been working with 32-bit stuff, and I don't know, I haven't owned a 32-bit computer, like a desktop computer, in years.
Right, right.
But,
So does it
you know,
have an
in the
NPU?
embedded space, we
Does
deal
it have
with-
a math processor in it, or why 64? Because ARM is so important that it's so important to have a big data application running on your ARM processor now, or why
Well, you know-
64? What are they going for? Graphics?
Looks like it's gonna compete with your PC.
But John, I mean, 64.
Not if it doesn't have major math on it.
Right.
Yeah.
This is my VM right here.
The iPhone, yeah.
Thank you. Yeah, okay, so there's multiple reasons
Keep the battery time down.
that 64 bits is pretty cool. One of the
Battery time
reasons
was creeping
is
up
you
too
can
much.
actually reduce power because of the memory allocator. It uses bigger chunks of memory. And so it doesn't need to thrash and churn your memory as much to pull some blocks of memory out of it. It could pull once instead of like, teensy tiny, little times, which memory access is the most expensive operation right now
When you're talking about
in computing.
moving it from like a ROM device to RAM,
From DDR to internal memory.
Yeah, that's the
you gotta
most
keep the
expensive
DDR
part.
hot too. So I mean, when you go double wide and then N deep, you still have to keep that DDR hot, so.
Yeah, cache lines are kept hot pretty, a lot better too, because like the L2 cache is, I think, at least guaranteed to be 64K, which is ironically or coincidentally the same size of the memory chunks. So I think before the memory chunks were like 8K.
So you're saying like 64K, there's a power justification to go to 64K?
Yes.
Are you serious? I mean, is this quantified, or is this like
It's pretty,
hype? Is this product
I
marketing?
don't have the data with me, but
Okay.
I can get it and bring it to
I
you
would really
for,
like
for,
to see
for the
that.
next show.
I mean, I'm not challenging, I'm just saying, it just sounds counterintuitive.
Yeah, a healthy bit of pessimism or skepticism is great, but it's true. That it's a very expensive operation to pull that memory. But not only that, there's a lot of other reasons to go 64-bit. I guess like the
That
math
fan,
stuff.
that fan, I mean, that stylish fan is another reason.
So it's,
Okay, so this is kind of an enterprise thing. If you look right here, there's like a fiber connection. I forget what we call those things, DEC or whatever, and all kinds of stuff. You're not big memory modules on an embedded kit. This is a development board, so it runs hot. This was a picture of, I believe, the first generation. I think we're getting into either the second or the third.
I don't know what this has to do with. This has to do with the fact that marijuana is illegal in Colorado now. That's where this came from.
I think
Well,
all
because
this
it makes
stuff
me
is
think,
being
what were
developed
they
in
smoking?
Silicon Valley, actually. So I think
Bigger-
they got stuff in the water there.
More is better.
So is the instruction set itself part of the NDA, or is that?
No. The ARM reference manual for this is out there.
Okay.
You just go in there, click-through agreement of some kind.
So Mike, I mean, if you buy an iPhone 5S today, it has the 64-bit ARM processor in it.
Okay,
And you can use GCC, you can use ARM assembler to write code for that thing. I mean,
okay.
anything makes you happy. You can do it on your phone. You just can install your own kernel on it, I guess. Or if you want to play with it, you can just get it.
Yeah, I've got one in the car.
Good.
So, one of the things that Fedora is into is enterprisey stuff. And I say that is because we're kind of upstream of another big Linux distro called Red Hat Enterprise Linux. And they're like a big billion-dollar company, ostensibly based on Fedora, off of a community effort.
Yeah.
So we are feeding, enterprise customers. And what enterprise customers want is super high density. We call it, somebody coined a word for it called hyperscale computing. So I guess it's one of these buzzwords. Basically, very low power, very high density. If a part fails on it, it's like a dead pixel on your LCD. You don't chunk the whole, thing out for a dead pixel. You just let it fail in place. You start getting all these new concepts where you really don't care about your hardware because, the individual core might cost you 10 cents or 10 bucks or something like that. Almost disposable. And that's the vision that we're going for. And for the enterprise stuff, we really do need 64 bits. Or at least the industry believes that's what we need. So we're chasing it. We're going for it. Everybody's chasing this right now. SUSE is chasing it, Ubuntu's chasing it, Debian's chasing it. There's like this little, silent war going on, I guess, Cold War. Who can build it out the first and quickest? I think, Debian, SUSE, and those guys are doing a pretty good job. I won't say how well we're doing, but we're doing pretty good too. So that's where it's going, is these things. Pretty soon this year, you'll be getting this kind of stuff. There's a lot of players in the market that just aren't revealing anything, and they're waiting for that big reveal. So Applied Micro is the first one. Virtualization is another big thing. This is going to be coming down to your phones. This is going to be coming into the enterprise-y type stuff as well. Right now, if you're looking for a good development board environment, you need to be using a Cortex A7, A12, or A15, or the new AR64. Basically all the latest stuff in the past few years has these virtualization extensions. If your chosen dev board is from a company that has a microarchitecture license, you may or may not have this. You'll just have to ask them. I'm talking about Snapdragon, those kind of guys like that. So, right now, all the virtualization developers that I am aware of are really digging on this QB truck. I don't know if any of you have that board, but it's from this guy.
Is it QB board or this is a newer name?
It's the QB truck.
Oh,
From
okay.
Tom Cuby. Tom Cuby is a wonderful fellow from, I can never pronounce it, Sichuan, China? Well, he's over there, and so he has access to cheap manufacturing, unlike we do, or more so than we do. So he's really turning around. He's pushing out all these all-winter boards, and now these rock chip boards. And everybody wants to do deals with him, it seems like. So, the Cortex A15 right now is my personal favorite. When I'm not using this thing, I use this. This is a Samsung 2012 Chromebook with a Cortex A15. It's the Exynos processor. I get 10 hours of battery life on this thing. It's just fine for what I need.
What's it having it for a battery? Just out of curiosity.
Say what?
How many milliamp hour battery is it gonna?
You know, I don't even know how many
Thin.
watt hours or whatever it has. It's
Thin, so.
I get a lot out of it. I go to DFW to Heathrow, and it doesn't run out of battery during the whole flight. So it has that much, you know. And I'm sitting there coding and piling.
Yeah.
So the Samsung Chromebook. There's also this Calzada Energy Core, but I don't know if some of you heard, this company just folded. It's one of these silicone vendors from Austin. They just closed. So I was going to do a demo here, but I didn't get it. I did not have the time to get it set up. I was actually going to open up the Chromebook over here and demonstrate launching Android in a VM.
Cool.
That's always a cool demo. I love doing that. We could just as well run another Linux distro on the ARM Cortex A15. So that's a really cool demo. I'll try to get that lined up for another visit around here. Okay, so the Fedora build system. In the Fedora landscape, I'm what you call a release engineer. Basically, it's kind of janitorial work. It's actually really fun and satisfying work for me. A distribution is basically the sum total of the contributors who provide packages to it. And then, you know, what I like to do is integrate all this stuff together into, it becomes a distribution, basically making the sausage. So we do this on this really fancy hardware. It's called a Boston Veritas, and this is kind of getting back to the enterprise ARM side of things. This is like a 2U chassis here that you can buy. It comes with 48, we got 2 of these things, and each one comes with 48 of these Calzada energy cores. Now, RIP Calzada, rest in peace, they just shrank down. I think they're looking for another round of funding or something. But this thing is pretty cool. You know, when we were promoting Fedora to a primary architecture, a lot of our main developers had a lot of reservations because they're used to our really super fast stuff, like enterprise Xeons, and they can just launch a compile job and it just goes. And it's true, ARM right now is a little bit slower than a Xeon. What's the analogy? It's like a Xeon is like driving a space shuttle to the grocery store for most tasks. That's what it's like. We really way over-engineered it. But we got the best that we can get, and we got this thing. So we got 2 of them fully populated. We have these, each energy core has 4 of these things on there. And this is an independent system right now. And each one of these has 4 cores apiece. So you got 16 right there, and then you can see that it's like, it's fully loaded there.
So what are you doing with this? Is this like rack and stack server room stuff, or?
Yeah, this is the hyperscale stuff. No, I wouldn't even call this hyperscale. This is just really super dense.
What are you doing?
The
What are you
future
guys
is going to
doing?
be even denser than this.
But what are you guys
He's
doing?
building the Linux distribution.
So which Cortex do you have in that? The specs for that? Like
Development?
These are A15s.
Oh, A15.
A15s. They do support the virtualization extensions, I believe, but we're not really doing that because we've got 96 of these things. So
So how do you make that go? I mean, everybody has their own little zone and then they just get busy, or?
Oh no, you must be using some kind of build farm system, right? So you Jekyll or something like that.
yeah, we have a build system. There's a lot of different build
Gather.
systems out there. Like, what's the one that Intel supports? Yocto is kind of like, well, it kind of does everything, but it's a build system. We have one called the Koji build system. I think Koji is a kind of Japanese wine or liquor or something. So yeah, basically we just put a daemon on there and it becomes a big build farm.
Right.
So, you know, the mothership sends it commands. We get all this stuff going in parallel.
So you're like doing a one module at a time compile and wide kind of a thing, or are you building it all at
Well,
once?
yeah, we build a big dependency graph of all the software in our distribution, and then we just kind of, we'll compile all the leaves and stuff that nothing depends on. And then,
Right.
go all the way up until everything's done. And we do everything as in parallel as we can. We are able to do an entire distro rebuild in 2 days. Now, I wouldn't expect any of you to be impressed by that, but it's impressive. It's super impressive. It's taken us months to do this in the past, with
That's
a
if it
whole
plays.
bunch of panda
That's if it
boards.
plays, that's if it plays.
That's what we used to do.
And you're not working for 5 days getting the build issues running out.
Yeah, so we're really lucky that we have
The 2 days.
Uncle Moneybags, Red Hat, sponsoring our development efforts. They every now and then feel generous and give us some nice hardware like this. Now, unfortunately, this hardware may be a dead end, as the company behind it, Calzada, is kind of like on life support right now, laying off people. So we're looking for new stuff. Hopefully, the next new thing is going to be 64-bit ARM.
But that's got the horsepower to last you for a while.
It does, and we're very happy with it. So this is the best thing you can get right now as far as the enterprise kind of ARM stuff.
So regarding that, just one more question. Like, I've seen people set up build system where, like, if someone is from some other country, then all they need to is just define the parameters, like just select that I want this module built, and then you just schedule the time and what time you want this build to be built, and it would just pass on this query to the build farm, the one that you had, and it'll just build it. Or would you just, sort of just like, log in, to that system and try to build it there? What do you normally do, like,
We have everything automated. We can log into it. We reserve a certain number of those energy cores, I guess those discrete units that you can SSH into and run a command to set up a proper build environment. That's how people troubleshoot things that sometimes go wrong. And so, yeah, we have both ways of going into it. I could probably go on and on about this, but I don't want to get too far into the weeds on it. 3D graphics. How many of you know Rob Clark? Okay. So Rob Clark was recently brought into Red Hat, and as far as I know, I'm not sure what he does. Obviously, he's doing like graphic-oriented stuff. But as far as I know, he just sits around and hacks all day on Fedora, which is really cool. And he's implementing it in Fedora, but he is the upstream for everybody. So I won't say it's exclusive or anything, but we're pretty tight with Rob Clark right now, and that's really great. I was actually going to have a Quake time demo. I was going to let you guys play some 3D games on my little Snapdragon board. I know you got one too.
Yeah.
And we're basically doing the same thing, just on different distros. But we got Rob Clark. So that's pretty cool. That's a really cool demo that, again, I wish I had the time to get that properly set up, because that'll really knock your socks off. There's a couple things that everybody wants to do, like, in my opinion, like the internet, and this may be distasteful, but, people want to play games, they want to look at, adult content, and read their email. And with the 3D stuff is going to unlock a lot of this potential to where the embedded Linux space is going to suddenly become like the main platform that people want to use to do the things that they need to do. All of it. So I'm really excited about that stuff. If we can get teenagers playing games on these things without needing big, power-sipping computer or power-hungry computers, I think that's a major win, you know. We'll save the world a little bit at a time.
Can you talk a little bit about what the Freedreno effort is? Some of these people
Okay.
may not know what that is.
I'm sorry, I went out of context. Okay, so Freedreno, what is that GPU that's in the Snapdragon? The Adreno.
Arduino.
It's like adrenaline.
Adreno.
Yeah.
It's the play on words. Rob Clark was a TI employee, and it was realized the hardware that they were putting out was based on this Power VR from Imagination, maybe a couple other players, but he was kind of under NDA with that, so he couldn't do anything with it. But he wanted to work on open source, and so he did. And Rob Clark, on his own time, started reverse engineering the Snapdragon CPU system on a chip, which contained this brand name of Adreno. And he had some pretty good success, more so than anyone else out there that's reverse engineering this stuff. And there's a lot of people. There's other 3D projects out there, open source. There's this one called Lima, and oh God, I'm forgetting all the names. Lima goes to the one that ARM puts out. ARM puts out graphics IP that a lot of people just choose to buy. But because they're in the business of selling this stuff, they don't really release the specs and stuff that we need to make 3D drivers. So there's people working on that. There's another one called Devonte, I think. And supposedly that one has open drivers. And there's a board you can buy, like an IMX6 board that has it, but I haven't tried it. Anyway, I guess I'm going off a little course. Rob Clark was working on this Adreno, and he calls it Freedreno. And he's basically implementing all the bindings necessary for OpenGL and the mobile versions of OpenGL that have emerged, like ES or whatever they're called. I don't think it's like, I think it's a subset of OpenGL.
GLES, yeah.
So that's what's going on. He's also working on this other thing called MESA, or MESA, which is kind of another layer in the stack. So I won't go too far into the weeds on it, but it's really cool stuff, and he's got the farthest of anybody. And he's a local yokel. He used to live in Dallas, and he lives somewhere away. Exactly. And I'll bring a quick demo the next time I show up. Hi, Dora. Okay. I thought this was worth mentioning, although I'm not a huge Raspberry Pi fan. And the reason is, everybody here's heard of the Raspberry Pi, right?
Oh, yeah.
Okay, so probably the most popular board out there, and it just goes to show you, if you sell things very cheaply,
You get every hacker buying one.
yeah, and they were kind of in on it early. So they experienced pretty good success. There's a lot of drama with them, though. They, you know, some of the things they say may not be entirely accurate and stuff. So, plus there's a lot. It's basically a GPU with 5% of the space consumed by, you know, that was left over on the silicon that they threw obsolete hardware onto that would fit there, this ARM v6, kind of lower end CPU, and it's really taken off. I'm surprised it's taken off. There is a remix of Fedora that's fully optimized for this version of this architecture. And it's pretty popular. I believe the Raspberry Pi people are now shipping it on their default image along with a couple of these like Debian-based ones. So that's really cool. Again, this is where you have distributions having little arms races. You know, who can optimize the best. You know. Who can make the best of a bad situation? So, you know. Does anybody still run a 486 computer? Probably not, right? Well, if you did, you know, basically this is like really optimizing the best performance out of your 486. And so we got that in the form of a remix. XKey or Allwinner. You guys need to be looking out for this because this is about to go upstream. Have any of you guys seen these little TV dongles? These cheap ones, they're like 20, 35 bucks from China.
The Android ones, right?
Yeah.
The Android on a stick ones. Those.
Yeah, I think they're called like 802 or 902.
What's it do?
Well, you can
Really
basically
store?
stick it on the HDMI port. It's kind of like a Chromecast actually, except it runs a full Linux distro on there, or an Android distro, actually.
Stream content to display on your TV.
I used one for a very long time to just sit there and browse the internet from my TV and goof off from, you know, my little HDMI dongle, and it's powered, you know, through a USB cable, which a lot of times the TV itself has. So it's this kind of little incestuous loop. That's kind of cool.
And it's got like Wi-Fi back to the net, or?
Yes, it
Okay.
does. They have little Wi-Fi radios. So these things are finally going upstream. Allwinner was really unique because they kind of independently arrived at the same conclusion that the Linux maintainers did, that we need a multi-platform kernel. They were selling these things so cheaply that so many integrators were building them out into different devices that they really wanted to have just one kernel, so they came up with something called effects file. And it's basically a better version of a device tree blob. And a device tree blob basically is just how you enumerate the hardware. You write down the hierarchy of the hardware, and in ARM, you can't really probe the hardware sometimes. You know, you need to hard code it in there, how to enumerate stuff. So that's what these effects files and DTPs do. At the moment, they're converting their way of doing things over to our way of doing things. So that's really cool. That's coming out in the next few months, I guess. The next cycle to be upon us is the 3.13. I think we're in the RC. So I guess we're talking about like 8, 10, 12 weeks or something. And suddenly, we're going to have a gazillion devices that are now supported by the Linus Torvalds kernel. It's really cool. We have a guy within our community that's like one of the principal players behind this push. So much to the point that he is now taking a risk and a gamble to go ahead and let Fedora carry the patches for these things, because they've been acknowledged upstream. They are going to go. And Fedora is a very big stickler about only using upstream. So if we are willing to go with that, it's pretty much a sure thing. So keep an eye out for that. I think we're getting kind of near to the end. We are at the end. Okay. As far as what I've been watching in the kernel, there isn't going to be too many new boards that are pushing upstream this cycle. I think for those of you that are BeagleBone users, I think the network and the USB on those is finally going to get fully worked out. And, yay, because that's probably one of my favorite things. That's a very inexpensive board. It's very capable. If you guys don't have one, I'd recommend you get one and play with it. What else? IMX6 is probably going to be the new popular kid. Remember in high school there was the popular kids? Well, I think right now it's IMX6. This Freescale company is just killing it out there. Everybody's building boards with that right now. And everything's upstreamed already. So all these people making boards need to do is, whirl out a device tree, and if you can get that upstream, you're good. You know, maybe do some U-boot. There you go. So that was it.
All right.
Thank you.
Thanks.